Hi everyone, welcome back to this series. This is Coding Concepts. Today we're going to cover statically typed languages and dynamically typed languages. So first of all, what are data types? So computers use ones and zeros, known as binary, for all data. Data types are a way to specify what binary represents and how much memory they take up. So you have loads of ones and zeros, like where does one thing start, where does one thing end? So say, for example, we have something like this. So what does this represent? Depends on what it is, to be honest. So it could be 193, it could be minus 65, or maybe something else. Or this. This could be 1, or it could be true. I mean, depends on what it is. So in C, for example, you would say char number equals 193, or signed char number equals minus 65. So one's signed, one's unsigned. Here we have char number equals 1. Here we have bool is true equals true. So we're specifying here what they are. Because underlying the numbers, how integers work, is the ones and zeros will represent numbers. So here we add, it's 1, here 3, here 7, 15, 31. That's how it works. The last digit will normally represent, either represents a number. If it's an unsigned integer, that means the last number is a number. If it's a signed integer, then this will be a minus sign or not. So if you make this 1, it goes to minus. Make it 0, it goes to plus. That's normally, so that's signed versus unsigned integers. So there are 4 main data types normally. So there's integers, which are whole numbers, strings or char, which is text, bool, which is true or false, and float, which is decimal numbers. So first, statically typed languages. These are languages where you are required to specify what type variables are. You are not allowed to reassign variables to other types, and types need to be converted manually. So some examples are C, C++, C#, Rust, Java, and Go. So here is an example in Java. So first we have void. So public static void. This basically means that this function returns nothing. And then we have string, and string is basically it's kind of a class in Java, but it basically represents an array of characters. And then we have join, which takes in 2 strings, because here at the top it returns a string and it takes in 2 strings as parameters. So A and B will be both strings, and then whatever comes out of the function will be a string. So we can't do something like this. We can't put a 0 into this function. This will give you an error. We also can't do this. We can't return 0 from it's expecting an integer. A string is an array of characters with varying size. If you try to put a number value into it, then the compiler won't know what to do. So say, for example, we have this string message equals hello. So this is basically what this would be in binary. So each of them is a byte. I believe it's like 2 bytes in Java, but it doesn't matter. 1 byte here. So this is basically the ASCII numbers for these letters. And then we have return 10, which is so a string is a collection of bytes, 8 bits. So it's a collection of bytes, and you're going to put in 4 bytes into that. It's like, what do I do with this? It makes no sense. So the compiler will not know what to do if you do this. So here's something a bit different. So we're using integers. So int add takes in an integer and takes in 2 integers and returns an integer. And then here we are putting in 2 integers and putting the result into an integer. Let's say, for example, we wanted to make it a float. So now we use a float here. This will give us an error. If we just do this, we have to convert it. Because it's returning an integer, we have to put an integer into a float. So we do this with brackets, like so. This is because, so for incompatible types, you will need to cast. This is where you convert one type to another, but keep the same value. This is because they are different in binary. So if you look in binary, they're completely different. Like 20 in integer and 20 in float are completely different things. So you need to convert them so it will actually keep the same value. So in some languages, we have the var keyword. And what the var keyword basically does is it will work out what it is. So you can only use the var keyword if it's obvious from context to the compiler what the variable is. I don't believe you can set it to nothing, like unassigned. Maybe it depends. But this could be anything. So say like variable could be here 10.1, could be high, depends. But then you could do something like this. Var variable equals other class dot get variable. Like, what does variable, what type is it? What is it? You don't really know. It's not really obvious. So you'd have to look at the class. You have to look at the class. Probably, okay, oh, it's an integer. All right, okay. So what you should probably do is something like this. So say something like time in milliseconds, timer dot get time in milliseconds, and then you can kind of guess. Oh, it's time in milliseconds. So it's probably an integer, because normally they'd be integers. So you should give things good names if you're going to use var, because it's not obvious from context sometimes. And then finally we have arrays. So here we're putting an array into the function and then printing it. And of course you can't put a single number in this, you have to put an array. So it actually specifies when you need an array, when you need a single variable, when you need multiple variables. So we obviously put an array into the function. Now dynamically typed languages. So these are languages where you are not required to specify what type variables are, and the language works it out for you. You're allowed to reassign variables to other variables, or to other types, and types are often converted automatically. Examples are Python, JavaScript, Ruby, Lua, PHP. So here's a Python example. So of number 10, print number, message high, print message, decimal number 1.1, print decimal number. So we don't specify the types at all. The interpreter, I guess, works it out for us. You can actually specify if you want. You can do something like this. So you can do number int equals 10, message string equals high, decimal number float equals 1.1. The problem with this is it actually does nothing in Python. It's simply there just to give you a hint. It doesn't actually do anything. So you could do something like this. Number int equals high, message string equals 1.1, decimal number float equals 10. And this will compile and work. So type declarations are hint only. So this compiles and runs. So it doesn't matter if you give it a hint that it's an integer. It will look at the actual data and then make it a string. So it doesn't really actually matter what you put there. It's simply just there as a hint for the programmer. So next we have here we have a function def add ab. So what are a and b? We don't know. It depends on what you put in. And we return a plus b. This won't work with some types, like a boolean it won't work at all, but you can put in here, say result equals add 10 and 10. And this will be an integer, and if you do this, and then we have result equals add high there, that'll be a string. Then we have result equals 1.1 plus 1.1, which is 2.2, which will be a float. As you can see here, we are redefining the same variable result twice. So first it's an integer, then it's a string, then it's a float. So you can do this. You can't do this in other languages, like statically typed languages. It won't work. You'll get a compile error because this block of memory would be for this block of memory for that. Each variable has their own block of memory. You can't redefine names. So the output here, yeah, it shows 20, high there, 2.2. So in a statically typed language, this will be called generics, which is basically where you can put any type into a function and it can still work. But it's a bit harder in statically typed languages. You kind of have to code for it. In dynamically typed languages, it's very easy to do generics, and you can normally just put it in. If you can plus two types together, it will work. So here we can actually do this. We can say a int, b int, and it returns an int. Problem is, again, this does literally nothing. It's just there to hint. It's just like kind of like an unwritten rule. You probably shouldn't do this, but again, I'm putting in add high there, and it still works. It still compiles. So you can put a string into this, it doesn't break, which is kind of the whole problem with these hints. You can break them if you want. So here I'll show you how. So number types are actually very weird in Python. They're kind of unique. I'm not sure if it's unique to other scripting languages, but here we have number 10 print number. This actually does is it actually creates a heap variable, which I believe will be 4 bytes initially. So it will create a stack variable, link into a heap variable. You can look at my video on stack versus heap if you don't know what I'm talking about. Say for example we reassign it. So now we say number equals what, 9 billion or something like this. So this is too big to fit in 4 bytes. So basically, we need more data. So what happens, Python will do this automatically. There is actually no upper limit to integers. They can go infinitely until you run out of memory, basically. So what happens is we allocate a different set of memory on the heap, and then we delete this link to the first block of memory. So that gets deleted. And then the garbage collector will come along and say, we have some unreferenced heap memory. Let's delete that. So let's get rid of this. Okay, we get rid of that. That's basically what happens under the hood when you set a new variable to something else and it doesn't fit. Of course, if you say like number equals 10, number equals 20, it won't need to create a new variable because it's in the same size. But if the size can't fit in the bytes, you have to create more heap memory. And it does this for you without telling you at all. And next we have printing arrays. So one problem you kind of have is you don't specify if it's an array or not. So if you give it a bad name, if you give it some like, number or input, like is it an array? Is it a single variable? You don't really know. Doesn't really tell you. So if you say do something like this, print array 10, it will give you an error because it has to iterate, and you can't iterate over one number. You have to iterate over an array. So this will give you an error. One of those only situations where it does actually give you an error if you put in the wrong type. Let's look at positives and negatives. So statically typed languages, the positives. First, less bugs and more predictable code. So if you know what types are, it's very predictable. You know what something is. It won't convert it for you unless you tell it to. So it just makes it less bugs and less unpredictable things, which just generally makes it easier to write things. Makes things clearer when reading code, so you normally know what types things are. You don't have to guess, you don't have to print them at runtime. So these languages are normally compiled, which offers better performance. Makes you understand the language better. So when you know what types are, for example, you try to, you divide a string. You say string divided by string. Of course, this won't work. When you actually use types, you learn this pretty quickly. But if you don't use types, you might not learn this. You might not understand what things are. What are strings? What are integers? What are floats? So it helps you understand the language more when you actually are forced to use them correctly and know what they are and actually give things names. And the negatives, harder to learn. So you have to actually understand these from the start. And it's harder to start going because you kind of need to learn what's an integer, what's a string, what's a float, what's a char. I mean, you have to learn all these things. You also have to learn about signed integers, unsigned integers, the difference, and takes more time to write because you have to write the types. So dynamically typed languages, the positives, easier to learn. It's basically the opposite. It's basically the opposite of what I just wrote, and less time to write. And generics are easy. So as I showed before, you can put multiple things into the same function, and it just works most of the time. Negatives, more bugs and less predictable code. As you don't know what types are, sometimes they can get converted. Sometimes you could redeclare a variable as something else and then try to use it as a string, and it will give you bugs. So it's generally less predictable, less clear what the code is doing. So as maybe you don't know what types things are, maybe you're not sure exactly what things are doing. What is that? What's this? Depends on depends on the situation, obviously. These languages are mostly interpreted, which has a performance cost. And lastly, obscures how the language works. So if you don't understand, what's an integer, what's a float, what's a string, you don't normally need to care at first. I'll kind of disprove that a bit later. So I'll give you some examples of why this can be bad sometimes. So the first example of why dynamically typed languages can cause some issues is unseen conversion. So the most infamous example comes from JavaScript. So imagine we want to sort a number array, just an array of integers, right? So obviously it should sort it in the right order. Let's see what happens. So we do this, and it's minus 10 minus... Wait, what? It's not really in order. This is because the sort array, and generally things in JavaScript do this, will default to converting to a string for some reason. I don't know why. So it converts it to a string, and then it just gives this weird mess. So just to fix this, you've got to do something kind of weird. What you got to do is you create a function compare numbers, a, b, and then you return a minus b, So it's returning an integer, but we're not specifying what it returns. And then we put that as an argument for sort. And then this will work. So that will work. But I thought that having, dynamic types should make the language easier. Because if I just make an array in like Java or, any other language that's statically typed, and I just do array.sort, it just works. So this is kind of making things more complicated, right? I thought it was supposed to make things easier. Of course, maybe JavaScript is an odd one out and probably not a good example. But let's look at something else in Python. So here we want to get the user age and then just print it in months. So of course you don't need to give things types. You don't need to know what types are. But do you need to understand what types are? My argument is yes, you do. Why? So what does input give you? Maybe you don't know. Well, it's probably going to give you a string because the user's going to write some text, so it's probably going to be string. But are you sure? What's a string? Well, how can I use a string? What type of functions are inbuilt for strings? You need to understand this to use the language and get good at it. So for example, here we have if age.isDigit. IsDigit is a function that only works for strings, and it's checking and will return false if there are not number characters in the string. And it only works for strings, but why do we need to do this? I mean, surely, well, you should understand, or you will learn, that you can't convert a string into an integer if it doesn't have a number in it. If there's like an A or a B or some letter in it, you can't convert it to an integer. Which is kind of my point. You need to actually understand what the types are. So you don't write them, but how do you understand what they are? Like eventually you have to learn this. So it kind of prolongs the learning period. And you don't actually truly understand how the language works. And then we'd have to convert it to an integer. So age equals int age. And then we say age in months equals age times 12. But say, for example, we're not sure, what types are these things? Well, you can use this thing where you print type, and it will print the type of the variable, because we're kind of redefining age, which can be a bit confusing. And this gives us, what is your age? 25. Class string, class int. So the string at the start, then we convert it to an int, then it's an int. What I would probably do is just simply give it good names. Age string is a string, equals input. Age string.isDigit, and then age int equals int there. Age of months int. So I'd give things good names to specify what the types are, so I would actually understand things. So generally, not having to write types means you don't understand the language a lot of the time, which generally isn't a good thing, normally. The more you understand, the better you are at programming, I believe. But it definitely is a lot easier to start when you don't have to write types. But that's all for this video. Let me know if you have any questions or any requests for future content. See you guys next time.